This is a counting circuit. A counting circuit is made up of several smaller integrated circuits and has the ability to make a 7-segment display, count from 0 to 9, and repeat until the first capacitor is fully discharged. The circuit begins with the analog input. The analog input decides whether or not the circuit experiences a high or a low input depending on the state of the button. Next is the analog oscillator. The signal is fed into it, where it then uses a combination of NAND gates and RC combinations to create a clock signal. The clock signal is then visualized as an oscillating LED. Here we can see both RCs. RC1 is responsible for the duration of the clock signal, and RC2 is responsible for the frequency of the clock signal. We can adjust the frequency and duration by adjusting the capacitors and resistors. This clock signal is then sent to the 4017 decade counter IC. The decade counter IC uses an output called the divide by 10 output, which multiplies the period length of the clock signal by 10, creating a slower clock wave. Next, the newly modified clock signal is sent to the 4510 IC, which converts it into a 4-bit binary output. Finally, the 4-bit binary values are fed into the 4511 IC, which converts them into 7 separate outputs, which the common cathode 7-segment display is able to read. It is then displayed as counting from 0 to 9, either up or down, depending on the 4510 chip. In order to complete this counting, the circuit uses 5 main components. First is the 411 NAND gate IC. Inside it, there are 4 separate NAND gates. Next is the 4017 decade counter IC. Its function is to slow the frequency of the clock signal by a factor of 10 using its divide by 10 output. Third is the 4510 decimal counting binary up-down counter. This IC's purpose is to transform the slowed clock signal coming from the 4017 IC into a 4-bit binary value, also known as binary coded decimal, BCD. The final IC is the 4511 binary counting decimal decoder. The purpose of this chip is to convert the binary coded decimal values into 7 separate outputs that can be transferred to a 7-segment display. The final component is a common cathode 7-segment display. Its purpose is to convert and display the values given by the 4511 IC as decimal numbers. It is able to count from 0 to 9 and then will reset from 0. Common cathode means that all of the cathodes of the LEDs inside the display are directly connected.